Hey everyone, welcome to the very last video in our series on the reactions of chapter 19. Uh, in total, this is the very last video for all of the reactions in this entire class. So after we finish this video, we're going to be done with every single reaction that is important for this class. So if you stuck with me this long, I sincerely appreciate it. And with that being said, in this video, we're going to be talking about synthesis of primary amines. So synthesis of primary amines. Okay, so in total, there's 5 ways to do this one. Okay, so going to be a lot to discuss here. First one is known as the Gabriel synthesis. Okay, so Gabriel synthesis uses something called phthalimide. All right, uses a phthalimide anion, and I start off with an alkyl halide. So I start off with some 1 degree or 2 degree alkyl halide. So we'll start off with this one, and it goes through an SN2 with phthalimide, the phthalimide anion. And this is what phthalimide looks like. So my phthalimide anion there. And then this is my first step. And my second step is hydrazine. So NH2, NH2 with some heat. And all this does is it takes that bromine and just replaces it with an NH2. Okay, pretty quick, pretty simple, not too bad. I can also do this with tosylates as well. So if I wanted to do this with some kind of tosylate, like OTS, no problem, that'll also work. So if I start off with that tosylate and again put this through with the same materials as last time, so my phthalimide anion followed by hydrazine with heat, then that's going to give me the primary amine. Okay, so this always forms primary amines, and it goes. This first step is an SN2 type mechanism there. Okay, so this is one way that we can do it. Now we get to talk about the other ways we can do it. So another way we can do it is reduction of azides. So reduction of azides is kind of similar to the phthalimide one. What happens is we take another alkyl halide. So we'll start off with the same one as last time, and we throw in NaN3, which is sodium azide. Sodium azide is going to do SN2 and replace the Br with an N3. And then we can use lithium aluminum hydride on the N3, on the azide, to turn it into an NH2. Okay, so we can turn that into an NH2 pretty easily. All right. Again, we can also do this with a tosylate. So if I do this with a tosylate, we'll do OTS on this one. Then what I can do is my first step, I add in NaN3, and then second step, I add in lithium aluminum hydride. And third step, I throw in some acid. Then I'm just going to get my amine. Okay, so this is reduction of azides. On the same page of reduction, there's also another way that we can do this. This is the third way, which is reduction of nitriles. So reduction of nitriles is very similar in that I need to start off with a 1 degree or 2 degree alkyl halide. So let's start off with a 1 degree first. So we'll start off with this 1 degree alkyl halide. and I will put in NaCN, which is sodium cyanide, which has a nitrile in it, right? CN's a nitrile, or well, CN is a cyanide group, but it will become a nitrile. And then this Cl just gets replaced by CN. Okay. And then all I need to do is throw in lithium aluminum hydride to reduce this into a primary amine. Now, the thing is that I have 4 carbons in this molecule plus this one that I added. So I have 5 carbons. So I'm in the beginning I had 4, but now I have 5 and I have the NH2. Okay. Because this C, I added this C and this N, right? Because I started off with 1, 2, 3, 4 carbons plus the Cl. But since I added a C and an N, right, then I added this carbon and I added this NH2, right? So I just need to make sure that I can I can keep track of that. So whenever I add in lithium aluminum hydride, then what happens is that I get that, okay? I get that addition of a carbon and an NH2 at the same time, all right? And this can also be done with tosylates as well. So if I start off with OTS, so with a tosylate or OMS, right? And my first step, I put in NaCN. And then I can also do a second step. Instead of lithium aluminum hydride, I can also put in H2 with PT. Okay. So if I put in H2 with PT, it's going to give me the same product. All right. So it's going to give me the same product. So I started off with 1, 2, 3 carbons, 1, 2, 3. But I'm going to end with 4 because I just added a carbon from the CN, right? And then I just make my primary amine and that's it. Okay. So that's all I need to know for reduction of nitriles and reduction of azides. Okay. These are my 2 ways to do it. Okay, so now let me get rid of this, and then there's also another reduction that we need to worry about. I think there's 2 more reductions that we need to worry about, maybe even 3. So the next reduction that we need to worry about is reduction of nitro compounds. Okay, so reduction of nitro groups. So if I take any nitro group, and we're just going to do one quick example of this one. This one's very low yield. I don't think we're going to be too worried about it. So in the first step, I throw in tin, which is SN, with H2SO4. And then in the second step, I just throw in NaOH and water. What happens is this NO2, which is a nitro, is going to get completely reduced into an NH2. Okay. So that's going to get completely reduced down into an NH2. Okay. So this is my reduction of nitro groups. Again, I just use tin with sulfuric acid and I use NaOH with water. Okay, that's going to reduce any of those into an NH2. Another reduction is reductive amination. So in the last video, we talked about amines as nucleophiles, right? And we discussed how to make imines, oximes, hydrozones, all that kind of stuff. Well, what we can do with those imines, hydrozones, oximes, all that kind of stuff is we can reduce them, okay? And we can reduce them to get certain groups, all right? So let's say that I start off with a ketone like this, right? And then I put in, under acidic conditions, I put in NH2OH, then that's going to give me an oxime, right? That gives me this oxime. So this oxime can be reduced, okay? And if I reduce this oxime, then it's going to give me a primary amine. Okay, so I can use lithium aluminum hydride, or I can use NaBH3CN. Okay, either one of those is going to reduce this oxime, and it's going to reduce that oxime into a primary amine. Okay, so that's how we reduce oximes. Okay. Imines as well. I can also reduce imines to get a secondary. So if I want to take some imine here, so in the first step, again, we're throwing in some acid, and then this molecule to give me an imine. So this is my imine. So now what I can do is just reduce this, and usually I use the NaBH3CN, and that's just going to reduce this into a secondary amine. Okay, so I've made a primary amine, a secondary amine. Finally, I can also make a tertiary amine. All right, so if I take this same thing, and again I have H plus, but I add NH with two methyl groups on it, right? I'm still going to make an imine, right? Except it's an iminium salt now, okay? So in this case, I make this thing, okay? Because this has two methyl groups on it, right? So I've made this. And I can reduce this by using a very similar reagent to the NaBH3CN. I'm going to use NaBH-OAC3, okay, with acetic acid. And what this gives me is a 3-degree amine. So this is a way to form a 1-degree amine, a 2-degree amine, or a 3-degree amine based on whether I have an oxime or an imine. Okay. Either way, I can reduce these. So this is reductive amination. Okay, so now we can look at acylation reduction, and then we're done. Okay, acylation reduction. So let me get rid of what we have here, and then we'll talk about acylation reduction. So acylation reduction is very similar to what we just looked at with reducing the imines and the oximes and all that kind of stuff. This is very, very similar. So as we discussed in the last video, right? Oh, let me write this. So acylation reduction. So in the last video, if I take an acid chloride, and I'm going to take the same acid chloride 3 times. If I take an acid chloride, I can add ammonia, or I can add an amine to that, right? So I can add, in this case, I'm going to add NH3. And what that does is it just replaces the chlorine, right? Just replaces that chlorine group. And I remove a hydrogen. So now what can happen is I can take this and I can reduce this with lithium aluminum hydride, followed by H3O plus. And what this gives me is just a primary amine. Okay. So the carbonyl group just goes away, and I get a primary amine. Okay, so that's literally all I did. I just took that carbonyl group and erased it. Okay, C double bond O, it's gone. All right. And we can do this with anything else as well, right? So if I take, for example, so this one gave me a 1 degree. I can also make 2 degree. So if I wanted to add this amine instead, right, then that would give me this, right, as an intermediate. And then again, I would use lithium aluminum hydride followed by acid. And then I just get rid of that carbonyl group and everything else stays the same. This is a good way to make a 2-degree amine. And then finally, we can also make a 3-degree amine as well, right? So if I use a secondary amine to attack this, so let's say we use something like this secondary amine, then I'm going to get this amide, right? And just like in the last two, I can reduce this with lithium aluminum hydride, followed by, followed by acid. And I just get rid of that carbonyl group. And now I've made a 3-degree amine. So in this case, I've made triethylamine, right? Very common base that we use. So that's it. Okay, so I think we covered 6 instead of 5. So I was thinking there was 5, but there was actually 6. So sorry about that. But so these are the 6 ways to form primary amines. And in this case, we formed primary, secondary, and tertiary amines, right? So there's, we're not just forming primary amines necessarily from these, but that was the main goal of a lot of these. We're forming primary amines. But I did want to show you some of the other ways that we can form different types of amines as well, aside from primary. So I thank you for watching this, and I thank you for watching for all the videos so far. This not only concludes chapter 19, but it concludes literally all the reactions for this entire class. So, hopefully these videos have been helpful. Sometimes I ramble on. Hopefully it hasn't been too bad. But yeah, thanks a lot for watching. And, be on the lookout for some videos on NMR, IR, and mass spec, hopefully. We'll see. So other than that, have a good one, and I'll see you.